Hello. In my today's presentation in video, I am going to explain a time history analysis, extended part of the time history analysis known as incremental dynamic analysis. In short, it is also known as IDA. So first of all, we'll see what are the basics of IDA curve, what are the characteristics, how to read the IDA curve pattern. Then what do we mean by selection of the ground motions? Then what is mean by a scaling of the ground motion? What are the methods to scale the ground motions and what is the purpose of doing scaling? And next is finally in relevant software like SAP 2000, how to develop the IDA curve. In my previous video, the link is also given in the description. We have discussed that the nonlinear analysis, seismic nonlinear analysis method. So there are two methods are there to estimate the inelastic deformation in the structure. First is known as static pushover method and second is known as a time history method. Time history method is more realistic because in this type of the analysis, the structure is actually subjected to the ground motion. So therefore, this is a realistic case. And the next part of this is the incremental dynamic analysis. That is the ground motion when it is applied with increasing intensities up to the failure. So that is a basis of incremental dynamic analysis. And this method was developed by a researcher, Wamascio, and the paper was also published. That is his work is also published in ASC journal. So this was the paper. So for the beginners, I recommend to refer this particular paper because all the details about the incremental dynamic analysis method was discussed in brief. So in this method, so actually what is IDA curve, how it is developed, what do we mean by intensity measure, how to select intensity measure, what is a building responses known as damage pattern, and what is the selection criteria about the damage pattern, what is multi-IDA curve, what is a single IDA curve. So all the basics of IDA curves and about the IDA method is given, discussed in this paper. So please refer this particular paper for more details. Okay, so now coming to the presentation. So whenever we apply a ground motion on the structure, okay, so there is a building response. There is a building response. So in IDA terms, so this whatever the intensity, whatever the ground motion we applied, so this is known as intensity measure. And the building response is known as a damage measure. Okay, there are certain parameters, okay, to describe this intensity measure, and there are certain parameters to describe the damage measure or building responses. And this is the structure on which we are applying the ground motion. So this is not a conventional type of the structure. Okay, so this structure is a nonlinear model. It is a nonlinear model. Now, how to convert the conventional model into nonlinear model? In my previous video, the link is also given in the description. I was discussed in detail. That is how to define the nonlinearity and how to assign the seismic nonlinearity to the structure. Now, this is a structure which is a nonlinear structure on which we are applying the ground motion with increasing intensity, and the outcome of IDA analysis is this particular curve. So this is a curve. So this is the relation between this particular curve is the relation between the ground motion, that is intensity measure, and the damage pattern, damage measure. So on the y-axis, this is the seismic intensity, and on the x-axis, this is a building response. And this is the pattern of the IDA curves. Now, in this figure or in this graph, there are 9 number of lines. So this is nothing but capacity curve. Okay, so that is response of, that is 9 number of ground motions were applied on the structure, and the response of the structure under each ground motion is a single line, represented by a single line. So since the 9 ground motions have different characteristics, so therefore response of the structure is also different. So these are known as the idea curves. Now, what are the other features of this idea curve? So this idea curve, or each curve, indicate the capacity of the structure, indicate a capacity of the structure, and therefore this is also called as a dynamic pusher curve. Dynamic pusher curve. Area under curve will give the energy dissipated during the earthquake. On y-axis, there is a seismic intensity. It is also known as the intensity measure. On x-axis, there is a building response. It is known as a damage measure. And this shows the global capacity of the structure. Each curve indicates the global capacity of the structure. That means here, these 9 lines indicating what is the capacity of the structure. Okay, so under the number of ground motions, what is called as a suit of ground motions. Then what are the characteristics of idea curve? Okay, so if we observe carefully, initially all the curves are showing the straight response. Okay, so it indicates elastic zone. It indicates the elastic zone, and at the end, all the curves are running straight. So indicate complete collapse. First phase is elastic pattern, elastic zone of the structure, and end it is a complete collapse. And in between elastic and up to the ultimate or final failure stage, the nature of the idea curve is wavy nature. That is, this is the first case. This is the elastic zone, and here actually there is a yielding of the members or yielding of the structure, and therefore because of the yielding there is a cracking, and because of the cracking there is a reduction in the stiffness, and therefore seismic resistance capacity will be reduced, and therefore the resisting capacity is low, therefore curve is the soften, behavior is a soften. Again, because of the strain hardening, again there is a increase in the stiffness and increasing the resisting capacity. Then rise will be there. Again, it is a softening behavior. Again, there is a rise. Again, softening behavior. And finally, it will be. So this is the general pattern of idea curve. Okay, this is not applicable to all ground motions. In some of the ground motions, initially it will be a elastic zone, and then the structure marches towards a failure. Okay, so mostly the nature is a wavy nature. And one more important feature of idea curve is the spread of the idea lines. Is a spread of the idea curves, as mentioned, point number 5th. Okay, so spread in the figure, this is the spread in the horizontal direction. This is the spread in the vertical direction. Okay, now this spread indicate capacity variation of the structure under the suit of ground motions. And since we are using this idea method just to predict the capacity, okay, just to predict the capacity, and therefore, as per as possible, whatever the spread of the idea curve should be as minimum as possible. Then we can say that whatever the capacity predicted is near to accurate. If suppose the spread is very large, so we are very much in confusion. So what is the exact capacity of the structure? Okay, so therefore, the care should be taken that after the analysis, when we generate this type of the curve, its spread should be as minimum possible. And this is possible only when whatever the ground motions we are taking for the analysis, there should be scaling. All the ground motions should be scaled first, and then it is applied one by one. Okay, now in the next part, we'll see what do you mean by scaling of the ground motions. Okay, these are the steps to perform IDA. First is a selection of the ground motion. Selection of the ground motion for the analysis. So how many number of ground motions required to perform IDA? There is no any specific rule for this. Minimum at least three should be three ground motions should be selected as per some of the researchers' suggestion, and maximum as we can in the sense because IDA is a time history analysis which takes more time to perform in the software, and therefore if a multi-story building is there, then again the time required is also very that is more time is required, and therefore 10 to 20 number of ground motions are more than sufficient to predict the building capacity or structural capacity. And in the researcher like Wamasco in his study also have taken the 20 number of ground motions. And these ground motions, okay, there is a selection. Okay, randomly we cannot take the ground motion and directly apply to the structure. So selection, there are selection criterions. That is, variety of the ground motions should be selected. That is, some ground, because ground motions, why actually the number of ground motion and with varied characteristics should be there? Because any earthquake, past earthquake never repeats. Okay, and to predict a capacity of the structure, so structure should be subjected to such a ground motions, that is all type of the ground motions. That is, some record should be from near field earthquake, some record should be far field earthquake, some ground motions should be from soft strata, hard strata, intermediate strata, deep focused earthquake, then shallow focused earthquake. So such a variety of the ground motion should be selected, should be considered for the analysis purpose. And the document like FEMA P695, there are some selection selection points also given. So we can, that is some suggestions also given in this particular document, in this particular code in Appendix A. Similarly, some of the researchers also suggested some points how to select the ground motion for the IDA analysis. Then after selection of the ground motion, all the ground motions should be scaled. There is a scaling is very important step, and just to minimize the spread of the IDA curve. That is the only. And again, there are methods. So many methods proposed by the researchers and in the codes also. In the present video, I am going to explain one step, which is very simple. One step scaling procedure. Okay, it was proposed by Wamasco. So that is a simple method is there. FEMA P695. So in this two-step scaling method is also given. So you can read that particular. And there are some softwares like a Sesmo Match is there, in which is typically used for scaling of the ground motions. Then after the selection of the ground motion and scaling of the ground motion, next is selection of intensity measure and damage measure. Okay, so on y-axis in IDA curve, on y-axis there is a seismic intensity, and seismic intensity is expressed in terms of some parameters. So what is the selection criteria for this particular parameter? Similarly, building response is on the x-axis, is taken on the x-axis, and building response is represented. Building response is measured in terms of different parameters, what is called as damage measures. And again, there is a selection for the damage measures. So that is the step number 3. And then finally, perform IDA using some relevant software like SAP2000. Okay, now first of all, we'll see about the selection of intensity measure and damage measures. Okay. Now this is the ground motion we are applying on the structure. After scaling, actually we have to apply this. Okay, now this ground motion has a different characteristics. Okay, and this characteristics is measured using different parameters, and this is known as intensity measure. So intensity measure is a ground motion characteristics measuring parameter. So how we measure the particular how we measure the characteristics of ground motion, either by using a moment magnitude. Okay, so that is, this particular earthquake is of 6.5 Richter, something like this. So it is a moment magnitude. Sometimes we describe as a in terms of duration. Sometimes it is expressed in terms of intensity. Then in terms of PGA, PGV, then PGD, peak ground displacement, or in terms of SAT1 5% damping. Okay. Among this, okay, all are the parameters which actually describe or define the characteristics of the ground motion. As per as the idea is concerned, we should have to select one parameter among all this, and that parameter must be a scalable. We can scale it. Okay, so such a parameter should be selected. Actually, moment magnitude, duration, intensity, these are non-scalable parameter, because, for example, moment magnitude, this is one single unique number. Okay, it is unique number. Or duration, this is also unique number. If it scale up and down, okay, the characteristics of the ground motion, it is that is these particular two parameters are such a parameters which are not directly influencing the total characteristics of the ground motion. Therefore, it is a non-scalable. Okay, so for idea purpose, there is no use of these particular parameters, but the parameter like PGA, PGV, PGD, and SAT1, these are such a parameters which we can scale. So therefore, it is called as scalable. So among this, we have to choose one. Okay, again, there is a selection. So in Wamasco paper, 2002 paper, in detail, the description is also given how to choose a particular parameter as an intensity measure. Actually, it depends on the type of the structure we have taken for the analysis. If the structure is a first mode dominated structure, that is a regular structure is there, then SAT1 5% damping will be the right choice. And if the structure is a torsion dominated structure is there, that is higher modes are also important in the analysis required to take into analysis, then PGA, PGV, PGD will be the right choice. But one thing is that whichever the intensity measure we select for the analysis, there should be proper reason why we have selected this particular analysis. So the user must know deeply the knowledge of each and every parameter and why we have selected this parameter for the analysis. Same case for the damage measure. Okay, so the building response is measured in terms of interstory drift, then roof displacement, then base shear is there, peak story ductility, peak floor acceleration, node rotations, and so on. So these are the some parameters. These are the parameters by which we measure the building responses. Among this, we have to select one. Again, there is a selection. Again, we have to apply some selection criteria here. And suppose we are very much interested about the ductility of the structure. Then we have to select such a parameter which is related with rotational deformations. For example, in that case, select interstory drift. Most researchers have prefer interstory drift because it is closely related with a ductility parameter. Or we can select a node rotations. Okay, but many researchers have used the other parameters also to while performing the intensity measure with their specific intention. Okay, with their specific intention. Okay, so this is about intensity measure and damage measure. Then these are the some selection criterions given in this FEMA P695 document. That is, moment magnitude should be greater than 6.5. That is, whatever the earthquake we are taking for the analysis, it must be a severe earthquake, and it should be taken from the ground motion should taken from some ground motion should be type A soil, B, C, and D type. PGA value should be greater than 2, PGV value should be greater than 15, like this. So these are the selection, for selection of the ground motions. These are the criteria are there. Again, here the user must be very much thorough about the selection of the ground motion, because what type of ground motions we are selecting to run the analysis, accordingly, as per our selected ground motion, we get this type of the curve, that is IDA curve. And this is, we are predicting the capacity of the structure. So capacity of the structure depends on the input, what type of ground motions we have selected. So therefore, again, the thorough knowledge, because many researchers have extensively worked on about the selection of the ground motions. Okay, so this is a very deep area about the selection of the ground motions, how many number of ground motions should be selected, what is the intensity measure, and what is the selection criteria for damage measures. So these areas are something deep. So those who are interested to work with IDA, first of all, read the literature very thoroughly and deeply study about all these particular parameter. And next is about the scaling of the ground motions. Okay, now this part is very important, how we do the scaling of the ground motion. As I said previously, scaling is required to just to minimize the spread of the IDA curve. Okay, so here I will explain one-step scaling procedure, which is proposed by Wamasco, and it is also is available in 2002 Wamasco paper. So this scaling is the scaling with respect to intensity measure SAT1. And by using the scaling, ultimately, we have to calculate what is known as a scale factor. In one-step scaling method, which is also called as a normalized scaling method, the scale factor formula is 1 divided by SAT1. Simple formula, 1 divided by SAT1, if SAT1 is the intensity measure. If your intensity measure is PGA, then scale factor will be 1 divided by PGA. If intensity measure is PGV, then scale factor will be 1 divided by PGV. So that means for in this one-step scaling procedure, just we must know what is actual SAT1 value, what is actual PG value, PGD value, and PGV value. Okay, now here, what is the basic of this one-step scaling procedure? First of all, whatever the structure, whatever the building under study, okay, calculate or do the analysis, modal analysis, and find out its first mode time period. Its first mode time period. Okay, that is the first we require that this particular value, and then calculate or get the value of SAT1. Get the value of SAT1, and SAT1 value we will get from the response spectrum. We'll get this value from response spectrum. So this is the selected ground motion record. This is the selection ground motion. Now there are many online sites are available from where we can download the past earthquake records. Now remember, we have to download two files. We have to download two files. First is the time history record, and number two, its response spectrum. Okay, just I will, for your understanding, I will show both files. This is one of the file. It is in the Excel format. So this is about the response spectrum. Okay, so this is the response spectrum of Northridge earthquake. So this is the brief description of that earthquake, which is triggered in 1994. Okay, and this is magnitude is 6.69. So all the description is there, and this particular file is about the response spectrum. The SA, that is spectral value, also I will show. Okay, so these are the values. Okay, we have to refer the unscaled as recorded. First column is the time period of the structure. First column is time period of the structure, and next three columns gives the acceleration value, spectral acceleration value. So remember, from every station, three readings were recorded. First is principal x direction, principal y direction, acceleration in y direction, and vertical acceleration. So in this particular sheet, this is x direction record, this is y direction record, and this is a acceleration in vertical direction. Okay. For the building, vertical acceleration is not required. We required either acceleration in x direction or y direction. And then how to get SA value from this particular sheet? So whatever our building time period, suppose building, we take an example. Suppose building time period is 2 seconds. Building time period is 2 seconds. Then what is the SA value in x direction? 0.03 something. Okay. Then the scale factor will be, for this particular case, 1 upon SAT1 value, because time period is 2 and the scale factor will be 1 divided by 0.023025. So it is 43. Scale factor will be 43. Just remember this value. If we take another record that is in the y direction, this is our choice. We can take this particular record for the analysis, and or we can take this particular, because both are in the horizontal direction. Okay, so these are the, and while downloading, we have to download one more sheet also. That is this sheet. So this is a acceleration record. This is a time history record. So this is in terms of G. So this is the second sheet it is required to download. So from this Excel sheet, which is downloaded from the Strong Motion database, so from which we get the SA value. Okay. Here I can explain in better way. So this is the selected ground motion. Okay, and this is its response spectrum. And the building is there. Its time period is known. Whatever the time period, say 2 seconds is the time period. Then read the SAT1 value. Okay, and after this reading this SAT1 value, then easily the scale factor will be equal to the scale factor equation is 1 divided by SAT1. That is, in this, what is the logic for this? This actual SAT1 value is normalized to 1. So for normalization purpose, what should be the scale factor? So that is, all the SAT1 values should be divided by actual SAT1 value. Then this particular ordinate will become a 1. Okay. Now, just now for the example, we have calculated the scale factor as a 43 something. Okay. Then whatever the acceleration records are there, whatever the acceleration record, acceleration value. So to each value, acceleration value, the scale factor is multiplied by 43, and therefore the original time history will be revised, and this is known as a normalized time history record. And this normalized time history record should be used for the IDA purpose. Okay, in the next slide also I will explain about this. So these are the two figures. This is the response spectrum before scaling, and this is the response spectrum after scaling. Now we have normalized this. Okay, so therefore all the lines are passing through a single point. And what is that point? The building time period. Whatever the building we have taken for the analysis, it's whatever the time period. So all the lines are passing through this particular line. Okay, so therefore, and again, you just watch the spread of the response per spread is also minimized. Okay, and this is the main reason why the idea curves, the spread is found to be minimum. So this will be the two figures if our SAT1 is the intensity measure. Instead of that, suppose we have taken the PGA as the intensity measure. Then after normalization, how the graph will be, response spectrum plot will be, it is passing through same line. So this is PGA value, which is normalized to 1. So all the lines will be, this is second line, this is the third line, this will be the fourth line, this will be fifth line, this will be sixth line, like this. So all they will be passing through the same PGA value, that is normalized value 1, just like here. Okay, so this is about the scaling of the ground motion. Then actually after calculating the scale factor in SAP 2000, where actually this scale factor should be given as the input, that I will show. Okay. So in the time history analysis, this is the window is here, and this is the table where actually we have to give the scale factor, define the scale factor. Now there are three numbers are there. First is a 9.81. We will call this scale factor as the scale factor A. Second is a 2.3. We will call this scale factor as scale factor B. And third is a 0.1. We will call this scale factor as scale factor C. Okay. Now I will explain what is A, what is B, and what is C. Okay. Now just now we have seen about the scaling of the ground motion, and by scaling up the ground motion, we have calculated scale factor as 43. So that is the input as a scale factor B. Remember, if we change the ground motion, SAT1 value will be different, then scale factor will be 1 divided by SAT1. So that scale factor is a scale factor B. Okay, remember. Okay. Then first is what is scale factor A? 9.81. So this is a scale factor which converts the time history, the record scale into model record. Okay. I will show it. I will show one one record. See. So this is one time history records. So what is the unit of this? We must read what is the unit of this. So this is all the this is acceleration readings are there, which are in terms of G. That means to each value we must have to multiply it by 9.81. Then it will convert into meter per second square. Why meter? Because our model unit is meter. Okay, so therefore the the scale factor, it is to just convert this time history scale into our model scale. Sometimes these time history records are in centimeter per second square. It is given in the centimeter per second square. So centimeter unit required to convert into meter, because our model unit is a meter. So therefore, in that case, the scale factor A will be 0.01. Okay, 0. That means to each value we have to divide by 100. So this is A is the scale factor, is just to convert into our model unit. Okay. And then third is a scale factor about C. Okay, now it is 0.1. Now we are performing incremental dynamic analysis. Incremental dynamic analysis means we have to apply the time history with increasing intensity. So first of all, take the first scale factor as 0.1. That is, whatever the ground motion is, intensity is reduced to 10%, then scale factor will be 0.1. It is not a rule that is 10, only 10%. Sometimes we can decide the steps as a 20%, 40%, 60%, and so on. If suppose our step is 10%, 20%, 30%, just go on increasing, in the first step, it will be 0.1. That means seismic intensity is reduced to only 10%. Then apply on the structure, note the maximum response. Okay, then come again and only change the C, scale factor C. Now, previously it was 0.1. Now in the next it is 0.2, complete analysis. Then again, rerun for the step number 3, 0.3. Okay, so that is, so every time we have to just change the scale factor C. So this is about the input in SAP 2000. Then finally, about the idea, it's very easy. See, this is the first, this is the structure, which is a nonlinear model. Now take the first ground motion, take its, reduce the intensity to say 0.1, that is 10%. So this is the ground motion, apply on the structure and note the maximum response in the structure. Whatever the response measuring parameter, note the maximum response, you will get the first point. Then increase the intensity to say next level. Okay, so just we have increased the intensity. That means what we have increased? Amplitude. Initially it was 10%, now it is 20%. Only there is a change in the amplitude. Rest of the other parameter, that is frequency content and duration of the are remain unchanged. I am stressing it is remain unchanged. And this type of the scaling is known as the scaling in the time domain. It is not frequency domain. Okay. Then we will get the second point. Again, also observe the failure pattern as compared to previous intensity. Since we have increased the intensity, failure pattern will be more failure will be there. Then go for the third. Go for the third step. So this we have increased to 30%. And then go for 40%, 50%, 60%. Just go on increasing the intensity by changing the scale factor, and then note the responses, and we'll get the point something like this. Okay, so this should be continue up to what level? Again, there might be a question about this. Okay, then we should have to, okay, we should have to stop the incrementing when numerical non-convergence is first encountered. Means what? All the points at the end somewhere, that is when we are increasing the intensity, a stage will come that is structure will be completely collapsed. In the analysis, how to identify this? When the, suppose we are building response parameter is a interstory drift. So initially you will find, you will get a drift value as 0.1%, then 0.4%, 0.6%, then 1%, 2%, something up to this level, 4%. Then finally, at a stage will come where the complete collapse has been occurred. The drift value is infinity. That is, it's very high values comparative to the previous value. Maybe 1000%, 2000%, that which is not a practical values. Okay, and it is supposed to be structure is completely collapsed. So when you are reaching at that particular level of the response, building response, then stop the analysis and then take all this particular value into the Excel software and then join it by taking appropriate spline and connect it. So this is the idea curve. This is idea curve. Then repeat the procedure for the ground motion 2, 3, 4, 5, and so on. Then whatever the ground motions you have taken it, you will get finally the suit of the ground motion is like this. Okay, so this is the incremental dynamic analysis. Okay, in my next video, by using this incremental dynamic curves or analysis, how to generate a fragility curve is the next part. So thank you.